My name is Conrad. I'm the Director of Education with Zorbit's Math Adventure. In my time working with Zorbit's Math Adventure, I've been able to research and see a really huge variety of different digital math resources that are out there. Some of them I've been really impressed with and been really fantastic, and others have been a little bit not so great. I've also had the privilege to speak with a really large number of teachers and educators, just like yourselves, to get a good understanding of what's being used in the classroom today across North America. My education experience includes teaching in the classroom for 6 years, as well as completing a Master's of Math Education, actually with a special focus in game-based learning. But my actual first experience with game-based learning was all the way back in 1993, when I played Math Blaster for the very first time. This was an awesome experience. This is in grade 4. We got to play Math Blaster, and we played Math Blaster right alongside, of course, Oregon Trail, the other classic. For Math Blaster, I was super impressed by how fun it was, even when I was a kid, but I couldn't help but think to myself, I wish that there was a little bit less math and a little bit more blaster. Because blasting was really fun, but the math just wasn't quite. The math questions didn't really seem to have anything to do with outer space. It was just kind of an equation and an outer space theme. But hey, this was all the way back in 1993. So I wonder, 25 years later, today in 2018, how far have digital math games come and what do they look like? Well, I went and found a random smattering of some different math games on the internet, and here's what I came up with. Okay, so this one actually looks pretty similar to Math Blaster. We've got a bunch of equations on screen and there's an outer space theme. Okay, well this one also has an equation on screen and we've got a meadow theme. This one, okay, well this has another equation on screen and this has a spy theme. Okay, well this also has another equation on screen and this is a zombie theme. And this one doesn't even have a theme to it, it's just an equation. Now, certainly not all games in 2018 look like this, but it's surprising how many of them exactly do. These kind of games represent absolutely the majority of different digital resources that are out there. If we were to take a look at the flip side and take a look at some really excellent examples that exemplify the kind of math and gameplay experience that can be found in a game-based learning platform, well, let's just take a look at one of them, for example. This is a game called Was It Trouble? This is an incredible example of game-based learning in action. So students use math in a really interactive, dynamic way to solve puzzles in this game. And all of the math is part of the environment and part of the atmosphere that the students are in. This isn't simply a math plus a gear theme game, but rather it has the math completely integrated into the heart of the game itself. So let's take a look at some of the numbers that are going on right now. Today, about 74% of all K-8 teachers are reporting using a digital game in their classroom. Now, unfortunately, of those 74%, they have to wade through all of the different educational apps that are in the App Store. And at last count, there was about 185,000 of them. Added on top of that as well is the constant fluctuation. There's about 2,500 new educational apps that are added every single month. So no one's got all that time to actually go through all these different apps and to try and figure out what's good. How are you supposed to go into there and look through this entire gigantic list and try and hand pick out some of the pieces that are really going to work for your class? So how do you know what works? How do you know what actually makes a good game? And how do you know what's actually going to improve student outcomes? And to give students a positive math learning experience? Well, in today's webinar, we're going to try and tackle exactly that. We've got 2 key objectives today. And the first one is to learn what traits make a really excellent educational game. The second key trait is to learn why games like this one simply don't make the grade. We're going to tackle these 2 key objectives by taking a look at 6 different questions you can ask yourself about a digital math resource. This is almost like your 6 themed rubric that you can take a look at. The first of these 3 questions are going to be focused on the math and the pedagogy that the students are experiencing. We're going to explore different ways of how the games present the math and how that can impact the student's ability to learn and to practice effectively. And the second set of 3 questions is actually going to be entirely focused on the gameplay. And we're going to talk about how the gameplay can impact the students' attitudes about math and how it can actually impact the quality of learning that's happening in the classroom. So without further ado, we're going to dive right in and start taking a look at some of the key questions that you can ask about the math in the game. And question number 1 is the math rich and rigorous? So as teachers, we're all probably guilty of giving our students a worksheet that looks like this. And this style of worksheet is definitely important for students to develop a procedural fluency and to help memorize their facts, which is really important for a strong foundation in the early years. But the only thing is that these worksheets aren't very interesting and they're not very engaging as well. On top of that, they also don't give this opportunity for students to actually think critically about the math that's involved. They just see a bunch of equations and they know how to solve a whole bunch of them. So is this really what we want our students to think of when they think of math? When students ask themselves that question, when will I ever need to know this? These kinds of problems are exactly why they're asking that question. Now, games give students the opportunity to actually interact with math in ways that a paper worksheet simply can't match. So this is an example from a game called Slice Fractions. In this game, we're using interactive game mechanics to actually teach students about fractions. Students play as the woolly mammoth that's down in the bottom left-hand corner, and all he needs to do is get across the screen, but there's a whole bunch of things that are in his way. There's some blocks full of lava, some blocks full of ice, and a big cloud of steam as well. So students need to slice up these different blocks into fractions to try and make equivalent fractions so that they'll melt a block of ice and get the woolly mammoth through the screen. Now, in a single problem of slice fractions, students need to critically think about the situation they're in. They need to develop a strategy to try and solve it, and then they have to put that strategy into action. Then on top of that, if they get a problem wrong, they actually need to reflect back on the strategy that they're using to try and resolve the problem in a different way. Now, there's no single best strategy to solve this problem. In fact, every student in the class might take a bit of a different approach. But I bet that if you asked each and every one of them, they would all be able to explain their thinking. Now, there's a lot of reasons why rich learning tasks are important, but three of the key ones are that they require students to think critically about the problem that they're in. And they have to develop problem-solving skills as well. They also let students practice knowledge transfer between domains. The rich learning tasks, at the end, they really empower and they motivate students to think about math in a different way and to think about all the strategies and operations that go into trying to solve something like this. So when you're in a game-based learning setting and you see a question like this, you might ask yourself, well, aside from rote math facts, why am I using a game for this? What relevant skills is this game actually teaching my students? So question number 2, is the math about more than just the answer? Again, how many times have we shown our students a question that looks like this? 2 plus 3 equals blank. And even with that underline there, it even emphasizes what students need to do. They all know when they see a problem like this, they've got to put an answer in that box. In fact, if students answer enough of these problems, they might start to think that the most important part of a math question is the answer. Now, in the context of a video game, this looks pretty similar again. 2 plus 3 equals blank. We've even got some multiple choice options down below. Now, the reason why it becomes a challenge to start thinking about having the emphasis being only on the answer in a math problem becomes really apparent when we start increasing the complexity of the problem. So let's take a look at a more challenging problem and see why this is a challenge. So Jim and Susie want to open up a lemonade stand, and they charge 35 cents for each cup of lemonade. They sell 28 cups during the day. Now, if they spend $5 on supplies, what was their profit? We've got 4 different answers down below. This problem is just complex enough that students are going to have to put effort into ensuring that they understand the question, they can develop a strategy, and they can calculate a solution. But the unfortunate part is the fact that the answer is right there in front of them. It's one of those 4 answers. And it's so tempting to just do the absolute minimum amount of work required and then circle that answer. So students that have the mindset that the answer is the most important part of the question, well, they're not really interested in the problem at all. They don't really care who Jim and Susie are. They're not really interested in the process or the strategy that they're using either. They're actually just interested in the answer. And I'll even take that further as well. They're not even really interested in the answer. They don't care how much they're making for money. They just want to know which one of those ones is going to give them the mark. There's a really interesting app out there called Photomath, which can actually take any problem from a textbook and just answer it for you. So finding answers to these rote problems is the one thing that computers are really good at. So it kind of makes you question, if we're just spending all of our time with students trying to find the right answer to a problem, are we really using them to their highest potential? Humans are really great for finding strategies to complex problems, not just the answers. Now, the open-ended nature of games is reflective of solutions to practical, real-life problems that might not have any prescribed solutions when they're first confronted. Games can foster the reasoning and inquiry that's really critical to being effective in a workforce, and it's rapidly moving past traditional structures and processes. Finding those strategies for complex problems, that's the real challenge we're trying to overcome here. So what does this question look like if we were instead to turn it into a game-based learning environment? Well, instead of learning about Jim and Susie's lemonade stand and hearing about how much money they made, why don't we open up our own lemonade stand and find how much money we make? So this is a cool app that I found online. I just called Lemonade Stand, I think. And in this app, we're actually going through the process of opening up our very own lemonade stand. Students even get to price out how much they want to charge for every single cup of lemonade. Here I've got it 35 cents a cup. And I get to choose how many pitchers of lemonade I'm going to make as well, and I have to stay within my budget. One of the coolest parts as well is there's no right or wrong answer here. Students get a graph at the end of each day's sales to find out how much profit or how much loss they made. And then they have to redevelop their strategy for the next day to see what they can do better. What kind of tweaks can they make to their strategy about what is the optimum price point and what is the optimum number of pitchers to make. The games have a really awesome ability to get students immersed in the process and the strategy of solving a problem. On to question number 3. So far, we've talked about 2 of the interesting ways of presenting math so that students can really tap into the learning. So the third question is also directly related to the previous 2, and it ties them both together really nicely. This is, does the math have opportunity for social learning? Collaborative learning can be a super powerful tool. Mathematics is a language after all. We practice writing it all the time, but we rarely have the opportunity to actually verbalize our thoughts and say them out loud. Offering and receiving ideas and explanations from your friends and peers helps us reflect on our own understanding of what the math is. Students also benefit from sharing the knowledge with each other. I mean, think of all the times that you've been teaching in front of a class and you realize that by the end of the lesson, you actually understood the topic so much better just by going through the process of teaching it. Collaboration can also be really motivating for students too. Helping out your friends and working together in a team can be a great experience. And so what kind of problems are really excellent opportunities for social learning? Well, here's one example that it's not. And this is a procedural problem that's again focused on the answer. Calvin, he just wants to know what the answer to this problem is so he can move on to the next one. And Susie, well, she's given him all the response that he needs. And this is all the social interaction that's going to go on with this kind of problem. In fact, this is probably even more conversation had Susie legitimately helped him. So instead, let's take a look at an example from DragonBox, an interactive game-based learning tool that actually teaches students how to solve algebra problems. Now, this screenshot, it doesn't look anything like algebra that you've probably seen before. And again, DragonBox is an interesting game-based learning application to be able to teach students about algebra in a really unique way. So in DragonBox, the left-hand side of the screen represents the left-hand side of an equation, and the right-hand side of the screen represents the right-hand side of the equation, with the line down the middle being like an equal sign. So just like when you're solving a regular algebra problem, you need to add or subtract the same amount to both sides of the equation at once. The students need to somehow rework all these different objects on screen, adding and taking away from both sides of the equation at the same time to try and isolate that DragonBox and see how much it's worth. Now, when students work together on a problem like DragonBox, well, the kinds of conversations that they're going to come up with is really, really fascinating. There's a really efficient solution to these problems, but there's also still so many ways to answer it correctly. And when you give students the opportunity to come up with their own ideas and to rationalize their thoughts, it can be a really powerful learning experience. There's actually a really fascinating study that was focused on exactly this. And these researchers found that when students worked through a game that used rote problems that focused just on the answer, well, they heard the conversation that students were having with each other, and they found that the conversation lacked mathematical depth, as the students were primarily concerned with just answers and speed. But when those same students were partnered up with a game like The Logical Journey of the Zumbinis, one that's really focused on rich problems and not just the solution, but more about the process, the conversation showed a great deal of mathematical talk about sorting, classifying, attributes, logic, and solution strategies. It was an entirely different way of thinking about the math and having a conversation about it. We're going to take things over to part 2 now, where we're going to shift our focus to be looking at the gameplay that's going on inside of math and seeing how that can impact a student's attitude. And the first question we'll take a look at is, does the gameplay make math the main focus? Now, if you want your students to actually be learning from your digital resource, it would be really nice if they spent the majority of the time actually focusing on the math at hand. Unfortunately, it was incredibly easy for me to find an example of a game that didn't do this, because so many of them don't. So this is a basketball math game where I've got 4 balls at the bottom of the screen and I get to throw them to make a basket. Okay, where's the math? I can't quite see it yet either, but maybe it'll come up at some point. So I'm using the cursor on the right-hand side to try and aim it left and right, and I get to choose how much power I'm going to throw it with, and it's pretty fun to play, actually. I get to throw my baskets, and maybe they're going to make it into the hoop, or maybe it'll go way over and fly into the city. It's actually kind of fun to do. But the problem is that when you run out of balls, throw, up pops a math problem. This is frustrating because I was just having a fun time throwing basketballs, and I want to keep on having that fun time, but now I'm actually getting interrupted by this, well, let's be frank, it's a pretty boring math problem. One of the main challenges here is that math isn't the focus, so it feels like math is getting in the way of actually having fun. This is a challenging thing for you as a teacher as well, because if you're to ask your students about their experience playing this game, the students might actually say that they enjoyed it. They might say, yeah, I like playing that basketball game. But if you probe a little bit deeper, maybe they actually only like the basketball part, and they thought that the math was actually kind of boring. Playing games like this reinforces the perception that math is just an arbitrary hurdle that you need to overcome in order to actually progress in the game. There's a number of games out there that have portions to it where actually no math takes place at all. This is an example of a game where there's a whole arcade section to the game that has nothing to do with education whatsoever. So during the regular game, when students are working on math problems, they're earning points and they're earning currency, and they can redeem those points to actually be playing these arcade games, which have nothing to do with any educational content at all. Essentially what we're doing here is we're treating math as the barrier to having fun. And when we do this, we're actually helping our students develop negative attitudes towards what math is. We're giving them the impression that math is so inherently uninteresting that it needs to be sugar-coated. If the only way that a game can motivate your student to do math is by giving them rewards like coins, gems, badges, or points, well then how do you think your students are going to react when they have to solve a problem away from the game world without that extra motivating factor? Let's take a look at a game that does things right. And this is a game called Counting Kingdom. So in Counting Kingdom, the math is not the obstacle, and it's not the thing that gets in the way of having fun, because in Counting Kingdom, math is actually how you have fun in the game. So in this game, you're a wizard in the bottom left-hand corner, and there's a whole bunch of monsters on screen that are attacking your castle. Now, as a wizard, you can shoot magic spells that are worth either 9 points or 10 points, but in order to shoot them, you have to select exactly the right sum of monsters so that they add up to the same amount of your points on the left-hand side. So when you make addition expressions by combining the right monsters together, you can let loose a huge spell to explode them all, which is really, really fun. This game does a lot of things right, but there's still actually an extra missing important element to really maximize the potential of a game like this. And that brings us over to our 5th question. Is the math actually integrated into the game world? In Counting Kingdom, students get to use math to cast spells and to blow up monsters, which is pretty cool, but then you might ask yourself a little bit, hold on a second, what do addition sensors actually have to do with casting spells? And why do the monsters actually have numbers on them? And what does the math have to do with any of this? Hold on a minute. So when students ask this question, why do we have to learn this? I'm sure all of us have tried to stumble over an answer when we're trying to come up for an answer for it. And it's a really good question that students bring up all the time, and it often is brought up when students don't understand exactly how math can be useful. When students see games where the math actually has nothing to do with the context in which it's applied, asking a question like this makes total sense. And Counting Kingdom, while it's really fun to play, it doesn't help students understand why math is actually a worthwhile thing to learn. Some games don't even hide the fact that math has nothing to do with the context of the game. So I'm pretty sure that there's some interesting ways that you can use math in the zombie apocalypse, but answering a multiple choice question, not one of them. What is a game? So what's an example of a game that where math is actually integrated into the world? So here's a game that's actually just called Pizza, and you get to run your own pizzeria. In this game, students get to shop at the market to estimate how many supplies they need, and they have to find the total cost of the ingredients and make sure they can stay within their budget. This is actually pretty similar to the lemonade stand game, actually. They get to decorate their pizzas, keeping in mind of the cost of ingredients, and then they also get to cost out how much they're going to sell their pizza for, in making sure that they can make a profit but aren't charging too much to turn away customers. Finally, on top of that, then come the customers who actually order the pizza, and students have to find the total cost for each customer's pizza. So in a game like this, students are actually getting to experience how math can be a useful thing to learn. It's really cool. Now, dare I say that the kinds of problems that the students are working on in this particular game are kind of like the real world problems that we always talk about. But a funny thing about real world problems is that they don't actually have to be directly related back to the real world. We can have completely fictitious examples that still use real world style problems. Let's take a look at one of those right now. This is a game called Was It Trouble again. And this has nothing to do with the real world, but we're focusing on some really interesting applications of mathematics here. Every mechanic in this game is directly tied back to the math that the students are working on. So in this game, we have to free the adorable little Was-It from the middle of this cage. And to do that, we have to rotate the large gear to the right amount so that the keys on it line up with the pointer at the very top. Now to do that, we can only rotate the 6 and the 12. So we can only rotate things in multiples of 6 and 12. And somehow we have to find the right combination of 6 and 12 such that we can get to all of those keys and unlock that Was-It. So this is a really interesting way that all of the math is completely integrated into the world of the game. Finally, we're on to our very last question here. Question number 3. Does the gameplay promote a growth mindset? So pioneered by Carol Dweck, growth mindset is the belief that your abilities in math and in learning and in life in general, they're not fixed and static, but rather they can always grow and progress. So by applying the optimism and effort and effective strategies, everyone has that potential to improve and to progress. Teaching students that their minds are malleable can be a really powerful tool for students to learn, especially at such a young age. As Carol said, tests tell you where your student is, but they don't tell you where a student can end up. Now, a well-designed game has a tremendous opportunity to help students develop a growth mindset. A well-designed game can make it so that failure in the game is a really interesting learning experience. And games can also give students instantaneous feedback to let them know how they can improve. So for example, in Minecraft, when you build a house and then it catches on fire, well, that is failure to the extreme, and you are definitely learning from this experience. You are not going to put a fire so close to your house next time. But then also the instantaneous feedback when you immediately know that something goes wrong, yeah, you know exactly what you can do better. And you know, a really interesting thing about a game like this, students are definitely going to persist through this mistake. They're going to persist and try again, and this time it's going to be improved and a little bit different. Games can also promote mastery, and they reward students for their hard work. This is a really interesting example of a game that awards students brain points, and they congratulate the student on working out their brain and for keeping on trying. Like, way to keep that effort up. It's really great to see. What a cool thing to reward them brain points instead of frivolous, just regular points, or money, or currency, or gems, or badges. Something that recognizes the effort and the challenge that the student went through. These kinds of games immediately give students an understanding of how they can improve on their work. The unfortunate thing, though, is that not all games actually promote a growth mindset in their students. And some games actually can help develop negative attitudes and fixed mindsets about math. So imagine a student that develops the attitude that getting a math question wrong is something to be feared. What if a game said this to you when you got a question wrong? Oh no, the game says. Even the character has a squinty eyes and they're gritting their teeth at you. This is brutal. As a student, if this is what I experienced when I answered a question wrong, I would lose confidence in my ability to answer questions that I was unsure of in the future. There's even examples of games where your character actually gets hurt when you answer questions wrong. And math anxiety is already enough of a challenge for educators to help students overcome. We don't need games that also exacerbate that anxiety. There's a couple of other really interesting key traits that you can look out for when you're engaging in a game to see how it helps the students develop a growth mindset. So you can look for games that celebrate persistence in a student. And you can avoid games that let students just avoid the challenge and get around it. Look out for games that reward a student's effort instead of rewarding how smart they are. And then look out for games that encourage students to try again, even with a different strategy, instead of punishing them or blaming them for the mistakes that they've made. So what have we discovered here today? We've seen a lot of different examples of digital games, both good and both bad. But the main thing we focused on in this discussion is how you can maximize the potential of a digital resource. So we took a look at 3 questions that you can ask yourself about the math and the pedagogy that's in the game. Is it rich and rigorous? Is it more than just the answer? And does it have an opportunity for social learning? And then we took a look at a couple of games that look like this and that just aren't worth the time. These kinds of games, again, they're just focused on that answer and they're just regular procedural problems. The kinds of conversations that a student can have about this would probably be pretty thin. Now, the funny thing about this is, though, these kind of problems are still important, but maybe they don't need to be in a game-based learning setting because there's so much more that a game can actually do. We also took a look at 3 different questions that are focused on the gameplay. Does the gameplay make math the main focus? Is the math integrated into the context of the game? And does the gameplay promote a growth mindset? We saw how games like this can really help to maximize the potential of a student. It offers a really interesting way that actually integrates and ties in all those pizza making skills with mathematics right into the narrative and the heart of the game, helping to encourage and promote the students' abilities. So what I would say to you all, and what I would like you all to do, is to take a look at these 6 different questions. And if you're currently using a digital resource, or if you're thinking about using one in the near future, just take a couple minutes to review these different questions alongside that digital resource and to see how well it lines up or doesn't line up. And maybe you can use this as a bit more of a rubric to try and judge whether or not that game is actually really living up to the potential that it can. Because some of those games, let's be honest, they're nothing more than a bunch of chocolate-covered broccoli.